You know, inside every single one of your cells, there's this incredible universe at work. And it's basically split into two completely different worlds. You've got the world of pure information, like the blueprints, and then you've got the world of raw energy and matter, the factory floor. So how on earth do these two worlds work right next to each other without just collapsing into total chaos? That's the amazing puzzle we're going to unpack right now.
So this is the big question, right? Where does the blueprint end and the actual building begin? How does the cell pull off this incredibly delicate, absolutely essential balancing act? Well, the answer? It's one of the most elegant design principles in all of biology.
The whole secret comes down to a boundary, a strict, and I mean non-negotiable boundary. The cell enforces this radical separation between how it handles information and how it handles energy and matter. It's a strategy that creates two completely separate domains.
And you can see these two worlds laid out right here. On one side, you have the information world. This is the world of symbols, of genetic code, and it all happens in this safe, watery environment of the cytosol. Then, on the other side, you have the energy world. This is all about physical forces, chemical gradients, folding, and it happens in and around the cell's membranes. Two totally different operating systems.
Okay, so let's dig into that information side for a second. How is this wall actually enforced? We tend to think of proteins being made in a place called the ER, but the most important part of that process, the actual reading of the instructions, which is called translation, that happens somewhere very, very specific for a very good reason.
And here it is, the absolute, unbreakable rule of the cell. All the machinery that decodes information, the mRNA blueprint, the tRNA molecules that bring the parts, the ribosome that acts as the decoder, all of it is strictly forbidden from ever setting foot inside the factory floor, this compartment we call the endoplasmic reticulum, or ER.
And it all comes down to this really beautiful, simple principle. The instructions, the pure information, they stay protected out in the cytosol. At the same time, the raw material, the brand new protein chain, gets threaded through the boundary and into the processing plant. It's a perfect separation of duties.
So why such a strict rule? Well, because the inside of the ER is basically a chemical war zone for a delicate molecule like RNA. It is just flooded with high calcium, it's got a harsh oxidizing environment, and it's full of enzymes that would literally shred RNA on contact. It's a place built for tough physical chemistry, not for fragile information.
So this brings us to the real job of the ER. And you gotta understand, it's not an assembly line. It's a quality control factory. And just like any high-tech factory, it needs a serious amount of power to keep the lights on and run all its tests.
So it's really crucial to change how we think about the ER. It doesn't read the blueprint. No. Instead, it takes the newly built product and puts it through a brutal series of physical tests. It finishes it, folds it, and ultimately decides if it's good enough to do its job.
And where does all the power for this quality control come from? Well, that would be the mitochondria. The easiest way to think about them is as the cell's charging stations, just constantly cranking out the power currency that the cell needs to function.
And that currency is a molecule called ATP. And you got to stop thinking of energy as some vague, abstract concept. ATP is a physical thing. It's a tangible, tiny, rechargeable molecular battery that gets spent to make things happen.
And the ER is a massive consumer of these little batteries. It's what we call an ATP sink. It doesn't make any power itself. It just burns through it. Every single quality check, every attempt to refold a protein, every decision to destroy a faulty one, it all costs ATP.
Okay, so this leads us to the most fascinating question in this whole story. If the ER, the quality control inspector, never gets to see the mRNA blueprint, how in the world does it know if a protein is made correctly? The answer has nothing to do with information. It's all about physics.
So yeah, think about that for a second. How does it do it? How does a quality control inspector do its job without the instruction manual? The cell solution is just ingenious. It's all based on physics. And here's the big reveal. The ER doesn't know anything. Not in the way we think of knowing. It doesn't compare the protein to some ideal picture in its head. Instead, it just performs a series of simple, direct, physical tests on the product itself.
So it runs three main tests. First, it pokes and prods for exposed sticky parts. If a protein hasn't folded correctly to hide its water-hating bits on the inside, it fails. Second, it uses a kind of sugar-based timer to see if the folding process is just taking way too long. And third, it checks the protein's internal chemical bonds to see if they've locked into a stable structure. It's all physical, no information required.
And you can sum up this whole philosophy with one perfect word: convergence.
See, the ER isn't looking for perfection based on a plan. It's just looking for the moment that the protein stops wiggling around and finally settles, or converges, into its most stable, final, low-energy shape.
And this lays out the brutal logic that follows. Has it converged? Is it stable? Has it taken too long? If the answer to all of those is yes, great, ship it out. If not, it gets another chance to fold, a chance paid for by ATP. But if it still fails, it's immediately targeted for destruction, because a misfolded protein can be toxic.
So let's zoom all the way out for this last part, because what we've been talking about, this whole system, isn't just some random quirk of the ER. It's actually a universal design principle for how life itself manages to exist in the universe.
Here's the first pillar of that grand design. The pure, fragile blueprint, the information, is always shielded from the messy, chaotic physical world of entropy.
And the reverse is just as true. That chaotic world of entropy is never allowed to go back and scribble on the blueprint. That boundary, that firewall, holds strong in both directions.
And this is the real punchline. Life doesn't exist in the information world alone, or in the energy world alone. It exists right there, on the boundary, in the carefully managed, controlled handshake between the two.
So what powers that handshake? What pays for this whole impossible balancing act against the constant pull of error and decay? ATP. Every single molecule of ATP that's spent is the cell literally buying another chance to get things right. It's paying to fight back against chaos.
And so we end here with what might be one of the best definitions of life I've ever heard. Life isn't a thing, it's a process. It's a process that works to keep precious information alive by constantly paying an energy tax to fight the relentless forces of entropy, one molecule, one fold, one single ATP at a time.